Hello, my name is Keshwani. This Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 465. Page 465. Today is our lesson number 22. We are about to do problem number 7 and 8 of the gradient questions. Let's take a look at it. Number 7. It says, the graph above is a parabola whose equation is ax squared plus 2, where a is constant. If y equals a over 3 x squared plus 2 and is the graph on the same axis, if the new graph is on the same axis, which of the following describes the resulting graph as compared with the graph above? Alright, big freaking deal. What they're basically telling you is this. Listen, pay no attention to what they're telling you. Don't make it so complicated. Start out with something simple. Here's your parabola. This is an equation of a parabola, and if you didn't know it, it only takes a couple of seconds to actually plot it out and see what it looks like. For example, when x is 0, y is 0. When x is 0, y is 0. When x is positive 1, the y is going to be positive 1 because it's 1 squared. When x is negative 1, again, negative 1 squared, positive or negative 1 squared. Positive or negative 1 squared is just 1. So when x is negative 1, it's also 1. When x is 2, they have to be comparable, that is too far away. When x is 2, y is 4. 1, 2, 3, 4, 4. There you go, there is your parabola. There is your parabola. What do you suppose is going to happen? What do you suppose is going to happen? So when x is plus or minus 2, y is 1. When x is plus or minus 2, y is 4. When x is plus or minus 3, y is 9, and so on and so forth. What do you suppose is going to happen if you were to take your original graph and instead of having y equal to x squared, if we had y equal to x squared over 3? What do you suppose will happen? Well, what will happen is that the values of the y for each given value of x, for each given value of x, the values of y will be 1/3 as much as before. Obviously there will be 1/3 as much as before. That's the whole bloody point of dividing it by 3. When you have a certain quantity and you divide by 3, you're taking 1/3 of it. So before x was 0, y was 0, that will still be true. This will be very difficult to actually show it here. Now when x is 1, y is going to be 1/3. It's going to be right down here. And when x is equal to 2, it's going to be 4 over 3. 4 over 3. Before it was 4, y was 4. When x was 2, 2 squared is 4. Now it's going to be 4 over 3. 4 over 3 is little over 1. So when x is 2, it's just a little over 1. It's up here somewhere. Before, this is 1 right here, right here. Let's do one more. When x is equal to 3, when x was equal to 3, y was 9. Now it's going to be 9 over 3. 9 over 3. 9 over 3 is just 3. So when x is 3, before the guy was 9. When x was minus 3, he was 9. Now it's just going to be 3. 3 is about here. 1, 2, 3. It's going to be right here. 1, 2, 3. It's going to be right here. So here's your new parabola. I'm going to draw it in a different color so you can see it. This red one is our new parabola. What happened to it? It became fatter. Why did it become fat? Because for each given value of x, y is now 1/3 as before. because the y is only 1/3 as before, it does not rise as much. In other words, here's what we're doing. In other words, we're taking our original graph, we're taking our original parabola, it looks like this, U shape, inverted, we're taking it like this and we're stretching it out. And by doing so, the values of y are being reduced. In order for y values to be 1/3 as before, we have to grab it by the two handles and stretch it out down towards x-axis. We are stretching it towards x-axis. It becomes wider, it becomes fatter, and that's it. That's what they're asking. What happens to it? It becomes wider. Now the fact that it has a constant in front of it, what do they call the constant? The constant is called a, and the fact that it has 2 in front afterwards, it plays no role. What does that 2 do? Let's talk about it for a second. What does that 2 do? I'm going to erase this. I shouldn't have put it right there because that part is separate. We're done with this part. Instead of having x squared, instead of having y equal to x squared, if you have y equals to x squared plus 2, what would that have done? That would not have stretched it. That would not have stretched it or bring it in towards y-axis. All that would have done is we would have picked it up and shifted it up 2 units. What this simply tells us is that the values of y are 2 more than before for each given value of x. For each given value of x now, the values of y are just going to be 2 more. In other words, what this does is that, here's your original parabola, it looks like this. Here's the original parabola, it looks like this. All this does is that you lift it up and you shift it up 2 units, that's all. These are parallel to each other. You pick it up and you lift it up 2 units, that's what this part does. But don't concentrate, don't pay attention to any unnecessary part. They're asking us what happens to it when you take 1/3 of it, because the other part is not changing. It's +2 in both cases. It's +2 in both cases. The new parabola and the old parabola is there already. So what's the point of paying attention to it? That part doesn't do anything. The constant a appears in both cases. That part plays no part in it. That part plays no role in it. The only thing that plays part is the fact that before it was values of y equal to x squared something. Now it's 1/3 as much. And because it's 1/3, it's being stretched out towards the x-axis. You're stretching it out towards the x-axis, hence making it fatter. Here's something you can do. What I want you to do is, here, type in this tag. Type in this tag, fat parabola, along with my name, and see what pops up. Do you understand? Another one that I had was, forget now. Something to do with, there you go, I remember it now. There is a word, if somebody, it was a pun that I was just having fun with. If somebody who is not of a good character, somebody who is a shady character, sometimes they are described as shifty. Here's another tag you can look for. Shifty grandpa. See what pops up. I'm not sure if I hyphenated grandpa or not. Something like that. Shifty grandpa. And fat parabola. See what comes up. Now if you really want to learn this concept of parabola in detail, so that you have thorough and complete understanding of this concept forever and ever, here are some videos that you can watch. I need to put this cap on before it gets too dry. Here are some videos I would like you to watch. Type in geometry for SAT. Type in this tag geometry for SAT and watch these days. Day number 35, just type in geometry for SAT, day 35 or 36 or 40 through 47, 41, 42, all the way up to 48. All of these days I spent talking about parabola. And we did quite a few problems dealing with concept of parabola. If you watch those videos in the entirety, if you take your time, as I said, you'll never have trouble with concept of parabola. There are 3 more days here. Again, geometry for SAT, day 37, 38 and 39. That's when we talked about the concept of circles. In the videos, as it pops up, you're going to see something like this. It's going to say revised GRE. Just ignore it. Ignore it. You just want to learn the geometry. It doesn't matter the fact that it says revised GRE in it. The basic geometry is the same in the SAT and the GRE. Do you understand? One more time. Geometry for SAT, day 35 and 36 and 40 through 47. That will take care of parabola. And 37, 38 and 39, those days will take care of circles. And look for those tags there. Fat parabola and shifty grandpa. Anyway, let's do the next problem. Number 8. I'm done with this thing. Okay. For each given value of x, in case you had trouble reading my handwriting, for each given value of x, the values of y will be 1/3 as much as before when you divide it by 3. That's all. Number 8. In number 8, here's what's going on. Apparently, we have this girl, Meredith. It's very sexy. Those are one of my favorite names, Meredith, Bertha. And what's the other one? I can't remember the third one. I'm being silly, you understand? Meredith has a red, my pronunciation is, my accent is what it is. Meredith has a red hat, a blue hat and a white hat. Oh, good for her. Also has 3 sweaters. Oh, very nice. 1 red one, 1 blue one, 1 white one. This girl is classy. And 3 pairs of jeans. 1 red one, 1 blue one, 1 white one. What do you know? Alright. She wants to wear a red, a white and a blue outfit consisting of 1 hat, 1 sweater and 1 pair of jeans. What a shame. I was going to give her 2 hats to put on top of each other. The question simply is, how many different possibilities are there? Well, let's find out. So here's her hat, here's her sweater, and here is her pair of jeans. And remember, there are 3 colors she has to choose from. She has to choose from either a red, a blue, or a white. Those are the only 3 colors she has, and she does not want 2 items of the same color. She does not want 2 items of the same color. What does she? Meredith wants to wear a red hat, wants to wear a red, white and blue outfit consisting of 1 hat, 1 sweater and 1 pair of jeans. How many different possibilities does she have? Where does it say that she does not want 2 colors? Meredith says, just give me a second, okay? She wants to wear a red, white and a blue outfit consisting of 1 hat, 1 sweater and 1 pair of jeans. Well, since she's allowed to wear the same color, then the answer should have been different from the one that I got, and yet it tells me in the book that my answer was correct. Number 8, was it? Number 8, section 5, B. That's what I put down. Meredith has a red hat, a blue hat and a white hat. Also has 3 sweaters, 1 red, 1 blue and 1 white, and 3 pair of jeans, 1 red, 1 blue and 1 white. She wants to wear a red, white and a blue outfit. Oh, there you go. She wants to wear, somewhere in the problem it had to say, I'm sorry, I kept missing it. She wants to wear a red, white and a blue outfit. In other words, they are telling us that she cannot have 2 items of the same color or 3 items of the same color. Do you understand? Since I made a big mess of the whole bloody thing, I'm going to actually show you what would have happened if she was allowed to do that. Let's first take care of this part. So she's not allowed to have 2 or more items of the same color. Well, ask yourself, how many different ways can she pick a hat? She has 3 hats, red, white and blue. How many different ways she can pick a hat? Well, there is only 3 ways she can pick a hat. Only 3 ways. Because those are only 3 hats she has. Once she has chosen a hat, let's suppose she has chosen a red hat, let's suppose. How many different ways can she pick a sweater? Well, there is only 2 different ways she can pick a sweater, because she's not allowed to wear a red sweater with a red hat. So she can either pick a blue sweater or a white sweater. Let's suppose that she picked a white sweater. There are 2 ways she could have picked a sweater. There is only 2 ways she could have chosen a sweater. Once she has chosen a sweater, how many different ways can she pick jeans? Well, picking a jeans at the end is not a matter of choice. It's not a matter of choice at all, because whichever color she has not chosen so far, that's the color jeans is going to be. So if she has chosen red hat and a white sweater, then the jeans would have to be blue. Oh, it's the blue jeans? What do you know? And that's not a matter of choice. That's just one way you can pick it, which is whatever is left. And therefore she has 6 different ways of choosing the outfit. Now let's do the problem where we will allow her to wear. Let's do one more problem. This is a bonus problem. This is not in the book. Here's the bonus one. What if What if she is allowed to wear 2 items of the same color? Then how many different ways can she choose her outfit? Well, there are 3 different ways she can pick a sweater. And then there are 3 different ways she can pick, this was a hat, the first one was a hat, not that it matters. There are 3 different ways she could choose our hat are the 3 colors, red, white and blue I think it was. Once she has chosen the hat, she still has a choice of picking 3 different sweaters, because if she chose whatever color she chose of the hat one, it doesn't matter, she can choose the same color of the sweater again. So there are 3 different ways she can choose a sweater. And once she has chosen a sweater and a hat, since she is not allowed more than 2 items of the same color, for the last item she only has 2 choices. Whichever color she has already chosen, she cannot choose that color for jeans, but she could choose any of the other 2 colors. In which case the answer would have been 3 times 3 times 2. 18 ways. There are 18 ways she can choose her outfit. Here there are only 6 ways. Now let's do one more. Last problem. What if she is allowed to wear 3 items of the same colors? Well, in that case there are 3 different ways she could use first item, there are 3 different ways she could have chosen the second item, and there are 3 different ways she could have chosen the third item, hence giving her 27 ways of picking the 3 items, which is what the answer choice E is. Answer choice E is for the people who were not paying attention, like I was about not to pay attention. Because for some reason I could not find in the question, where does it say in the question that she cannot have more than 1 item of the same color? Well, it says right there. I don't know how I kept skipping that sentence. Which is why it's so important to take your time to read the bloody thing properly. She wants to wear a red, white and a blue outfit consisting of 1 hat. See, she wants to wear, there I missed it again. She wants to wear a red, white and a blue outfit. That's their way of saying she cannot have 2 items of the same color. That's their way of saying she must have each item of the unique color. You understand? I'll see you tomorrow, okay? Bye now.